Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1297, relates to an ELD circuit low voltage issue in the 2012 to 2017 Honda Accord. The acronym ELD stands for Electric Load Detector, a critical component that monitors the electric load on the vehicle's electrical system. When an error like P1297 appears, it indicates that the electric load reading is lower than expected, which can cause various electrical performance issues. Understanding the implications of this DTC involves checking the ELD's operation and diagnosing its broader impact on vehicle performance. This presentation will guide you through troubleshooting steps, including verification methods, potential causes, and corrective actions. We will also discuss components involved and their location in the Honda Accord, ensuring a comprehensive understanding of the issue. The DTC P1297 indicates a low voltage condition detected by the Electric Load Detector, ELD, within the vehicle's electrical system. The ELD is responsible for assessing the electrical load and communicating with the Powertrain Control Module, PCM. Positioned in the engine compartment, the ELD's correct functioning is essential for optimal performance of electrical systems such as the alternator and battery. If the detected electric load falls below 72 amperes, the DTC is set, causing potential issues with electrical components and overall engine performance. As a result, diagnosing and addressing this error promptly is crucial to avoid further complications in the vehicle's operation. The freeze frame data collected can provide critical insights into the vehicle's behavior at the time of the DTC's occurrence. The P1297 error code can stem from several potential issues that need to be investigated thoroughly. One primary cause may be a faulty electric load detector, ELD, which, if malfunctioning, would transmit incorrect load values to the PCM. Another cause could involve a shorted wire within the ELD circuit, resulting in abnormal readings or loss of connectivity. Furthermore, the issue could also derive from loose connections between the ELD and the PCM, where intermittent contact disrupts readings. Each of these possible causes requires methodical checking to isolate the root issue. It is essential to address these problems timely to ensure the vehicle's electric system operates correctly without additional errors arising. When dealing with DTC P1297, certain symptoms may become apparent while operating the vehicle. Drivers may notice reduced efficiency in the electrical system, manifesting as dimming lights or malfunctions in electrical accessories. Additionally, engine performance may deteriorate, particularly during high-load scenarios where the ELD would play a crucial role in managing the electrical demand. If the ELD value remains consistently low, warnings may appear on the dashboard, further indicating the need for diagnostic attention. These symptoms are crucial cues that can alert drivers to underlying problems associated with the ELD. Recognition of these signs helps in timely diagnosis and prevents further complications related to electrical malfunctions. In the first troubleshooting step for DTC P1297, the process begins with verifying that the ignition is set to the on mode. This step is crucial as it allows the necessary systems to engage, providing accurate readings from the Honda Diagnostic System, HDS. Once this condition is met, the specific parameter of the electric load value, ELD, should be checked. The expected reading should be more than 72 amperes. If the readings meet this threshold, it confirms that the current conditions are replicated and the failure is ongoing. However, if the values do not meet this requirement, it indicates a potential intermittent fault, prompting a check for poor connections or loose terminals, both at the ELD and PCM locations. Moving on to the second step in resolving DTC P1297, You must start by disconnecting the ELD 3P connector. This connector houses vital wiring that links the ELD to the rest of the electrical system. After disconnection, it's important to turn the ignition back to the on mode to recheck the electric load value using the HDS. The same threshold is applied here. Readings must once again exceed 72 amperes. If the ELD value exceeds this limit, it suggests the issue lies within the ELD unit itself, and it should be replaced. Conversely, if the readings fall below this threshold, further investigation is warranted before concluding that a replacement is necessary. The third troubleshooting step for DTC P1297 involves checking for potential shorts in the ELD wire. The process begins with ensuring the ignition is set to lock or off mode before proceeding. The HDS is then used to jump the SCS line, which stands for Service Check Signal, allowing for a proper assessment of the integrity of the wiring. Following this, the PCM connector A is disconnected to facilitate testing. Continuity tests must be performed between the designated test points to determine if a short exists in the wire connecting the PCM to the ELD. If continuity is found, this indicates a short in the ELD wire, which can be repaired accordingly. If no continuity is detected, the ELD wire is deemed functional, requiring an update of the PCM software or testing with a known good PCM to further isolate the issue. After successfully completing the necessary repairs associated with DTC P1297, it is essential to conduct a final repair verification. The first action is to ensure that all connectors, especially those related to the ELD and PCM, are securely reconnected. Subsequently, the ignition should be set to lock mode before using the HDS to exit the Service Check Signal SCS mode. After this, the HDS will be employed to reset the Powertrain Control Module PCM. Performing this reset helps clear any previously stored DTCs and prepares the vehicle for normal operation. Once the reset is complete, the engine should be started and the headlights turned on to replicate normal conditions. Finally, a thorough check for any pending or confirmed DTCs is critical to ensure the issue is fully resolved and no further problems are present. In conclusion, DTC P1297 highlights a critical concern with the electric load detector circuit within the Honda Accord. Our troubleshooting guide emphasizes the importance of effectively diagnosing electrical system issues through detailed testing and observation of symptomatology. We covered significant steps, including parameter verification, continuity testing, and thorough inspections to ensure connectivity between the ELD and the PCM. Effective early detection and rectification can prevent larger systemic issues that may affect overall vehicle performance. Regular maintenance checks should also be encouraged to monitor the health of components like the ELD, ensuring they function optimally in conjunction with the electrical system. By following these guidelines, automotive technicians can provide effective service and maintain vehicle integrity. Please like and subscribe to the channel. See you next time.